class, so today we are working on polygons and angle relationships. So a little fun fact here at the beginning. It says the sum of the interior angles of a polygon is related to how many triangles can be formed by drawing diagonals from one vertex of the polygon. Okay, so first thing, number of sides. If we look here, we have 1, 2, 3, 4. Okay, so we have 4 sides. Now, it says number of diagonals from one vertex. So if we go here, I could go straight across. And if I look, I have 1, 2 triangles. So number of triangles formed was 2. Number of diagonals from one vertex, I just had the 1. Okay, and this is called a quadrilateral. Okay, and then sum of interior angles. Well, because we made 2 triangles, we go 2 times. Well, the inside of one triangle is 180 degrees. So if you multiply that together, 2 times 180 degrees gives you 360 degrees. Okay, next one. If we look here, number of sides, 1, 2, 3, 4, 5. So we have 5 sides. This one is called a pentagon. Okay, so we're going to go from one vertex. Let's pick this middle. I'm going to draw a line here to make a triangle and here to make a triangle. So I drew 2 lines, and then I have 1, 2, 3 triangles. So to figure out the sum of the interior angles, I'm going to have 3 times 180 because each triangle is 180 degrees. And when you multiply those together, you get 540 degrees. Next one, we have 1, 2, 3, 4, 5, 6 sides. So 6 sides, oops, wrong one. Why aren't you changing? Okay, 6 sides. This one is called a hexagon. All right, so if I picked one point, I'll just pick over here. I'll go straight down to make one triangle, then over, and then over. So I just drew 3 lines. And if I count, I have 1, 2, 3, 4 triangles. So now it's going to be 4 times 180 degrees. And that gives me 720 degrees. Next one. 1, 2, 3, 4, 5, 6, 7. So we have 7 sides. Okay, I'm going to go here, 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 and here. So I just drew 1, 2, 3, 4 diagonals. So that means I have 1, 2, 3, 4, 5 triangles. So 5 times 180 degrees gives me 900 degrees. Okay, so if we look at these first couple, to go from 360 to 540, you had to add 180 degrees, which makes sense because we just added another triangle. To go from the 3 triangles to the 4 triangles, we added another 180 degrees. Okay, adding another 180 degrees. Okay, so there's a little pattern there. Let's go to the next ones. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, so if I were, this is called an octagon. Okay, and I'm going to draw here, draw here, draw here, draw here, draw here. So if you count the number of lines I drew, it was 5. And we have 1, 2, 3, 4, 5, 6 triangles. Okay, so we're going to do 6 times 180 degrees. Okay, and that gives us 1080 degrees. All right, next one. We have a decagon. Well, let's figure this out first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we just jumped to 10 sides. Okay, if you were to draw your little triangle, so 1, 2, 3, 4, 5, 6, 7. Okay, so I did 7 lines, and that means I have 1, 2, 3, 4, 5, 6, 7, 8 triangles. So 8 times 180 degrees for each triangle gives me 1,440 degrees. Use your calculators to make sure that I'm doing this right, okay? And this was called a decagon. 10 sides is a decagon. Okay, this one looks crazy. Let's count the sides here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have 12 sides, okay? This is called a dodecagon. Dodecagon. All right, so if we were to look at our triangles, oh, it's going to get harder. Oh, that's not very good. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I just did 9 lines, and that means I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. Okay, and now that means 10 triangles times 180 degrees for each triangle. We now have 1,800 degrees total inside of a dodecagon. Okay, so it says, using the pattern in the table, we can create a formula to calculate the sum of the interior angles of a polygon. So S stands for the sum of the angles. So we know it's 180 degrees. Okay, so 180 degrees. And then if we look here, we had the number of sides, say 12, and then we had 10 triangles. Here, number of sides, 10. We made 8 triangles. Number of sides, 8. We made 6 triangles. Are you seeing a pattern there? So to go from sides to the number of triangles, we subtracted 2. 10 to 8. Subtract 2. 12 to 10. Subtract 2. So we do number of sides, which is our n, subtract 2. So S stands for the sum of interior angles, and N stands for the number of sides. All right, so next we're going to do some examples. So it says calculate the sum of the interior angles of nonagon. Okay, so this is a tricky one. This actually means 9 sides. Okay, so 9 sides. We know that we have our formula, S equals, so if we look back here, S equals 180 times, in bracket, n minus 2. So let's start with that. 180 in our bracket, n minus 2. So let's fill in what we know. We want to know what the sum is. So if I just highlight here, okay, so we want to calculate the sum of the interior angles of a nonagon, so 9 sides. So let's fill in black. Okay, so S equals, we have 180, but instead of n, we replace n with the number of sides, okay, which we know is 9. So 9 minus 2. Okay, so then S equals 180, and we know that 9 minus 2 is 7. So that in your calculator, we can just move, maybe I can't move it with that thing. Oh, stop it. 1 second. Oh, whatever. Okay, put it in your calculator. It's not working for me right now. And when you put all that in, you will get 1,260 degrees. All right, so let's try the other one. It says calculate the sum of the interior angles. So let's highlight what we're looking for. The sum of the interior angles, okay, of an Hexagon. Okay, so that means 20 sides. Okay, oopsie. 20 sides. Okay, so we use the exact same formula. S equals 180 in brackets n minus 2. And then we fill in what we know. 180. N is 20. Subtract 2. And then S equals, you keep your 180, but then we take 20 minus 2, which gives us 18. And then when you multiply 180 times 18, you will get 3,240 degrees. Okay, so using this formula is like a lifesaver, especially when you get up to these like crazy high number of sides, okay? So now let's do some more examples. So it says angle measures in regular polygons. So in a regular polygon, all sides have the same length and all angles are equal. Using the sum of the interior angles pattern or rule, we can calculate the measure of each interior angle of any regular polygon. Okay, so if we look at the first one, it says calculate the measure of the interior angles of each regular polygon. Well, if we look here, we have 1, 2, 3, 4, 5 sides. And that means that this angle, this angle, this angle, this angle, and this angle are all the same. So we have a pentagon. And we know that a pentagon has 5 interior angles. So to figure out the interior angles, we know, remember before, if we were to draw, we would end up with 1, 2, 3 triangles. So 180 times 3 gives us 540 degrees. So the interior angles of a pentagon are 540 degrees. Okay? So because we have 540 degrees inside this whole pentagon, we need to figure out what each angle is. And if we look here, we have 1, 2, 3, 4, 5. So that means we're going to take 540 and we're going to divide it by the 5. So 540 degrees divided by 5 angles, because we know they're the exact same. And when you put that in your calculator, you end up with 108 degrees each. The next part, it says a regular decagon. Well, we said earlier that a decagon had 10 sides. Okay, so if we have 10 sides, that means we have 10 interior angles. So if we have 10 interior angles, that means that we had 8 in total triangles, remember? So if you were to do 8 and you multiplied it by 180, you get wrong one. So we have a total of 1,440 degrees, and we are dividing by 10. Okay, so when you take 1,440 divided by 10, you end up with each interior angle being 144 degrees each. Okay, next page. Okay, I'm actually going to pause here and start this on a separate video. I'll be right back.